so how this is going to look like on our SDOH toolkit side. Let's go back one here. Okay, so you're familiar with the previous modules. Now there's two new modules that were actually published. So it's the Spatial Data Wrangling module. So everything here is kind of showing you how to, or it's going to be the main content. And then there's going to be specific activities. Pretty much almost every activity in this section, like we just talked about, spatial data formats, will have an option in R as well. So the appendix is basically going to be your space for working with data wrangling in R. And for those of you who are interested in making dashboard applications, you can also make, there's an extension of R is Shiny, R Shiny, that can make a pretty efficient dashboard as well to kind of as one of your coding options later on. We linked to a couple of really helpful tutorials at the very beginning. For our workshop today, you mainly need to know how to set up a working directory, which I'll show you how to do in a second, and have installed your packages, which I'll show you how to. I'll show you how to do at least one. And the basic part is just working with file management in your folder. So that's the bare minimum that will make your life a lot easier, but the code here will work. So just having something that works right off the bat will make your life a little bit easier. Okay, so let's kick things off. So I have started, and I usually have a separate folder where I put my coding environment. And so that's in this folder called code. And right now I have this folder called SDOH in place. And all the data that I extracted is in this folder called data. Okay, so you guys all see that, yes? Okay. I'm going to open up my RStudio environment. We're going to be using the word RStudio and Posit Cloud kind of interchangeably because I know that for those of you who are senior R users, you may agree or disagree with that. But basically, Posit, so R and RStudio, I'm going to create a new file here. Or actually, yeah, we can just exit out of all of this. But when you're, so RStudio is this interface that we see right here. It has a lot of different information. We have our console up here, which is the R itself. We have our file folder dictionary right here. This is going to be where we're going to be practicing good file management. We have, in this case, there's a script right here, and I can create a new script. So if you want to follow along, you can, click new file script, and we'll save this a little bit later. And we have our environment right down here. I'm stumbling over this a little bit in part just to kind of highlight that a lot of those intro level tutorials will take you through this environment, but just to kind of orient you a little bit more. But right now I put my folder in desktop. So I'm going to access the desktop. I'm going to access this folder, SDOH in place, and I'm going to create, here, we'll just start from the scratch. I'm going to create a new R script and save this as working tutorial. You can name it whatever you'd like, okay? All right, so here I have my working tutorial, and then I have my data that includes all the different data that was included before. Note that the CSV files will look like this. Those of you who used R a lot will be familiar with that. The GeoJSON file will just be one file like this. And then here's the frustrating file, the shape file. The shape file has many different extensions, and they all have to be in the same folder in order for you to work with it, okay? So in this case, I have all of these in a folder called data. I'm going to go back to my main folder right here and click on this little icon right there to set as working directory. So here I'm setting my working directory. I'm going to just put this up here in my environment. This is a really common classic error that a lot of first-time R users make, where they're mixing up where they're setting their working directory and they're not accessing their data correctly. So that's why I'm just doing this part a little bit more slowly. Okay. So next, we wanted to make sure that we had a couple different packages, right? So I'm going to kind of go a little bit split screen here. And in this case, I've already downloaded a lot of these libraries. So for example, if I've already downloaded library SF, I'm going to, so you can either highlight this and click run. I'll just put my cursor on that same row and hit command return to run that. Okay, so this is essentially loading this library called SF into my environment. SF is the workhorse of spatial analysis in R. I can go on and on about how wonderful SF is, but that will be for another day. And we can do the same thing for these other packages. If you don't have these packages, what you can do with our notebook is actually copy the code here to install and paste this in your environment and install. So again, you can hit command return. I'm actually not sure if I have ggplot because I usually use tmap, but let's try that. Okay, so I did not have ggplot and now I do have ggplot, and that works. So I'm going to go down here again. So Yilin Liu are one of our postdocs, not yet, PhD students, helped fold in our module today, and she really loves ggplot. I really love tmap. So that's part of the reason you're going to see a little bit of both today. But so SF is going to be doing all your spatial data wrangling. It is a super powerful library. dplyr is going to be kind of the modern non-spatial equivalent. So you could also, instead of bringing in library and alternate, is the tidyverse, or just tidyverse by itself. So these two are the workhorse of, again, non-spatial data, extremely efficient. SF is completely compatible with the tidyverse, and that makes your life a lot easier. These two down here are going to be your mapping libraries, your cartographic libraries. So ggplot will present some figures. Their focus is non-spatial, but they do have spatial in it as well. And then tmap is exclusively focused on kind of vector data, which we'll be working with a lot. Okay. So, grand opening, how do we open a spatial data set? Well, here we're going to start with just opening up a tracked file of Chicago. So I'm going to click right here to open, or to copy that. And we're going to just paste that right here. We can add a comment if we'd like. Open Chicago tracks. So those who are new to R, we can make comments like this. Here, if I were to run this right now, it's going to give me an error. It says that the file doesn't exist. When you're working, when there's a file management error, that is going to be the error that you see. And this can happen in a variety of different cases. Why is this happening? It's because here, the sample code is looking for a folder called SDOH place data wrangling, but I have my data in a folder called data. So I'm going to just change that and run this again. And it has read that layer correctly, okay? It's understanding it as a polygon. It sees the data as having 801 features or rows, and then 9 columns or fields. Everyone in R will have their own, favorite way of looking at the data. I like using the head function because it looks at the first 6 rows. And here you can see that this spatial data set also has regular data, right? This comes directly from the City of Chicago data portal. And that usually means that it's a bit messy. So we have community area numbers that are duplicated. We have these 10-digit code GeoID numbers, which we'll talk about a little bit later. We have these 6-digit track numbers. This is basically a version, like just the last 6 of the GeoID, and the census tract name, and so on and so forth. Because SF is super compatible with modern R, you could potentially just hit plot and look at it directly. Okay. All right, come on, plot. So while that's thinking, I mean, this is usually what shows up right away. Sometimes I've learned if I'm using Zoom at the same time. There we go. So this is plotting the data, and it's actually going to plot the first 10 columns. So for example, community area numbers, this is creating a map of color coding each of those numbers. And this is kind of a way just to inspect and look at your data super quickly. All right, so where we were, we had just plotted our census tracts here. Now I'm going to map this, not just, so plot is kind of just a quick way to look at all the data or the first 10 columns at once and the first, measure of that. Now we're going to switch that into this ggplot function. So ggplot is just one way of visualizing graphics. Okay, so here I can change the title of my map here. I can also update some captions, and later there'll be examples where you can actually turn this into a color-coded map or thematic map, and so forth. So we're working with this spatial data. As you can see, ggplot is already, this ggplot knows where this map is in the world based on the metadata, right? Based on the data that we can't necessarily see, but that the spatial format is telling us. So this is all the regular data of the census tract file, but SF is storing the geometry field in this new column, and all the coordinates are included within that. Okay. For those of you who have ever worked with SQL, there's an extension of SQL, or especially in PostgreSQL, called PostGIS. And SQL is working the same way when it's dealing with spatial data, or at least when you're working with PostGIS. And it turns out that SF and PostGIS are actually using the same standard. So anything that you're learning how to do using SF, like ST-read, you're going to have, if not identical, a really similar function to do something, again, similar or identical in SQL, in PostGIS. So that's kind of a pro tip later on. So we have this data set, but let's say that we want to know what the coordinate reference system is. STCRS is going to give us that information. So this is not a point and click software. We can just immediately ask, like, what is the definition of our coordinate reference system? And here we are told that it is WGS 84. Okay. And down here is the EPSG code 4326. So distance is actually going to be in degrees. So this is, distance is in degrees, is angles. That is not conducive to a lot of spatial analysis where we might need to measure distance as feet or miles or kilometers and that sort of thing. So let's say we want to transform to a new coordinate reference system. Here, I'm actually going to just Google, good wording computer. I'm going to Google EPSG Illinois feet. And that is actually going to, anyone else who has been Googling something like this has probably been a spatial data person looking for an EPSG that is using, that is projected, that is going to be using feet or kilometers. So there's a couple different options here. 3435 ends up being a really common one. So let's say we decide that we want to transform into a new coordinate reference system. So we grab this here. In this case, let's say I'm going to put this on this side. Oh, no, yeah, that's fine. And all I have to do is transform. I'm going to call the track that I want to transform, and then I'm going to specify which EPSG I want to use. And here I'm going to write it to a new file called tritracks.3435. This new file is only existing within R for now, because I'm not going to write it necessarily anywhere else. So I've done that. If I want to go over here and look at the coordinate reference system of tritracks 3435, I can do that. And now I have different metadata. This metadata now shows that I'm in a different coordinate reference system, the North American datum from 1983. Here, my distance is going to be in feet. If you want to get really nerdy, this is a transverse Mercator projection, and so on and so forth. So here, this is actually going to be super optimal. It's actually like a survey topographic mapping. Like the precision is going to be pretty good for the area that we're in. Okay. And I think one of the reasons I actually switched to coding from using ArcGIS for a really long time before I was a QGIS user is because it's just so fast. It's really beautiful. So here is just a really quick, simple plot code and this is using kind of native R, so without using any fancy libraries. Sometimes using a simple plot function like this. It's just, again, another way that you can visualize things. Okay, so here we have our new datum. And if we wanted to, we could also try other EPSGs just to see how different it might be. So for example, if we tried 6633, how would that change our information, right? Okay. So let's say we want to change it to 6633, which is just a projection that's focused for Hawaii. And I can change my main thing here into EPSG. And this is obviously not the right projection for our area, right? So again, just being familiar with projections and how they work. That's often like one of the hardest things to think about when you're first switching over to working with spatial data. And then for those of you who have already been working with spatial data as GI scientists, because we also have, GIS professors here, it's pretty amazing to be able to do this so quickly within R in such a user-friendly way that is also analogous to working with SQL if you wanted to do that. And with that, let's switch over because I think we'll almost be done with time. Here, we're going to now try a little bit of work with TMAP, which is going to be our cartographic software essentially for work or cartographic library. So ggplot can do a lot, and I appreciate that. But TMAP is really made for spatial or cartographic folks. So the way TMAP works is there's always going to be two parameters of any kind of map. You have the spatial object itself. In this case, it's going to say that I want to map tritracks. And then depending on what type of spatial data it is, you're going to have additional parameters. Like here, it's a polygon. I want to make my borders slightly transparent. So this is kind of the default map for TMAP. Alpha, the reason that we bring this here is because it's just one of the best hacks possible for making your maps really beautiful. Just adjusting the how thick or thin your borders are will make, or how transparent they are can make a map really pop out. And kind of, and here again, you can do it immediately. You don't have to go into the point and click software and click a million different symbology updates. It's pretty immediate. So here we're going to make this a little fancier now. I'm going to delete that. So here we take the same area, but now we're actually going to make the transparency a little more transparent, we're going to add this color, gray 10. So you can actually use any R kind of color base for this. We can get more into that later. For inside the polygon, we can also color that a specific color. So we're going to fill the inside of each census tract a gray, like a light gray, and then the borders will be a slightly darker gray. We're going to also add in a scale bar and put that on the lower left side. And we're going to take our frame away just to make it look a little bit nicer. Okay. So here it's already starting to look a little bit classier, and there's a lot that you can do with that. So in this case, we're going to be working with some new data, right? We're going to grab this housing development data set that was pulled from the City of Chicago data portal. Let's grab this and inspect it. And so here we can see that we have information about specific places. So this is the management company, the property name right here, like Hope Manor Village. And as you can see here, there's also some missing data for some of the coordinates. Here you can actually see there's two different coordinate systems. There's a latitude, longitude, which is, again, incorrectly specified by web developers in this location column, but also this other coordinate system. So in our case, let's say we didn't know which coordinate reference system was used in either. I actually don't think either was even mentioned in the data portal, and we're going to try to work with the lat and long. Before we can work with it, we have to think about those null values. So we're not going to be able to turn null values into spatial data. So just to be super short and efficient, in this case, we're going to just lose them. We're going to remove the null values. It's not perfect, but it is what it is. If you really needed that data, you can geocode it potentially later, which we'll do in just a couple minutes. And then here's the magic. This happens with just one line of code. We're going to use ST as SF. So this is going to cast cleaned housing, this CSV, and we're specifying what the coordinates are, longitude, latitude, and we're specifying what coordinate reference system is being used. Aha, and actually that is not the right one. So this should be 4326. Okay. So now if we look at it, we can see that there's this new column called geometry that has that point data. And before, so Beth had asked about layering. So let's just quickly try this out. So here I have my census tract data right there. And let's say I want to add another layer. I'm going to add my second layer right here as my point housing. And because this is point data, I need to use a specific parameter that can help style it. So in this case, I'll just use TM dots. We can say that the size will be what? Oh, here, actually, let me redo this. There we go. Okay, yeah. Do you guys see that okay? Okay. And we can make it actually maybe a little bit smaller. Awesome. So we have that. If I wanted to contextualize this with a base map, there's a really great option here by just switching our view from plot, which is the default, into view. So if I run that and I rerun this line of code, I can actually now see the same information within a base map environment. Let me just make the dots a little bit smaller. Okay. And here, the base map, we can also try out other base maps. And it's pretty fun because you can actually zoom in and really inspect things as you need. You can also save this as a web page. And, think that, yeah. So there's, if you click zoom, it gives you an option to really inspect further, which can be very useful. And also, pro tip, this is a really helpful way of testing how your final maps will look like if you wanted to take something like this and put it into your own web application, which is what we'll be doing in a couple weeks. Okay. So there we go with that. And now let's switch over to geocoding. So for this, we're going to be working with a library called Tidy Geocoder. In this case, we're going to be working with a new data set of methadone providers in the Chicago area. So here, methadone is an evidence-based medication for opioid use disorder. Our team studies access to these kinds of medications. So that's one of the reasons why this is an example. And again, we're thinking about this as like from an SDOH perspective of what are different resources that are available within an area. So here we're going to read this, look at it. Here in this data set, it's pretty simple. We just have the name, the address, and the location of where it is, and that's it. Well, we're going to have to convert this into coordinates. So in this case, we're going to be using the US Census and OpenStreetMap geocoders. With Tidy Geocoder, you can use this cascade option where it will actually check for that address across two different services. So each of those have their pros and cons, but they're both open to use and not proprietary, which makes it really helpful for us. So let's just try maybe with one first. So let's just try to geocode this one address here using this cascade method. If you wanted to figure out what other methods to use, you would just look for the Google Tidy Geocoder method, and you'd be able to get that information. Okay, so here we do get some information that the geocoding is done, and it's given us a latitude and longitude. Okay, and that works out pretty well, right? So here, if we like that, and again, always test out geocoding with one to start, just to make sure you're doing things correctly. Next up is let's get everything else ready so that we can have this set up as for the geocoding service specifically. And this geocoding service wants all of the information as characters. So we kind of convert everything to that. And all of this is going to be added at, well, rather not just characters, but it wants all of this as one address field. Other geocoding services, especially in the no-code groups, will want them separated, but for this API service, essentially, it wants it as one full field. So we add that in as this new field in methadone clinics. We can look at that really quickly. So we can see this brand new option that we have here. And let's do this. And here, we're going to, instead of using geo, we're going to use the batch geocoding service, geocode. We assign the full address as our address, latitude, longitude. This is, we want it to be called latitude and longitude, so that's why we're writing it that way. And we geocode. And it's already completed. It took 0.6 seconds. And if we want to see what that looks like, we can right here. And everything has been geocoded. Or if it didn't geocode it correctly, which sometimes happens, you can also just omit the latitudes, or you can omit the ones that didn't geocode correctly. And sometimes they might not geocode correctly because there's an issue with the data quality. So this is that pre-processing step where you might really have to delve into, depending on how successful your geocoding is. If it's not very successful, you might have to go back and do a lot of manual inspections and different things to kind of fix that address level data. Cool. We can also cast this CSV as a point data set. And now we could also add, let's take this one up here. And just for fun, we can try, let's see. Oh. Okay. We're going to just add another row here. And go from there. Awesome. So we have all of this. I'm going to switch back to a plot view. All right. And so let's start off with a classically messy data set. And it's not really that messy, but it's just like the classic EPI format. So here, let's see. Oh, yep, I got the wrong one here. There we go. So let's look at this data set to see what's in it first. So this is actually data that we also pulled right off a data portal. This is information about weekly cumulative case counts, test counts of COVID cases. So in this case, we have, this is definitely long format. It might not look like that here, but if you inspect, we have 60603 show up twice. And it's because every week number has a different data set. So let's see. First, we can just grab a couple of those rows, and there's many different ways to subset data as well. You know, so keep that in mind. You don't have to use the format that we're using here. I actually really like using select from dplyr, where you just type in, you could do the same thing actually. So this is using base R functions, but you could also use, you know, select COVID and then just type the names of the different options that you have here of what you want to keep. Okay. Oh, I think that's because I didn't write this in here earlier. Okay. So this is pulling it the same way. Let's say we wanted to, oh, actually, here. We could also kind of further filter this by including just a specific number or a specific week number if we wanted to. Okay. So here we're going to, all right, we've got all this information. Okay. All right, so first we're going to create, so again, one option is we filter and we could potentially just grab all of the week numbers that equal the specific week that we have an interest. But what if we want a brand new data set that essentially every 606 there shows up as one row, and then we have all the cases throughout the rest of it to highlight. Yeah. So for example, here we have cumulative cases for week 16, cumulative cases for week 15, and so on and so forth. You can see that with the pandemic, as some of the numbers went up, there was more likely to be more cases because it was spreading further and further, right? So this is a really powerful function here that we're going to be using by dplyr. It's also automatically in the tidyverse package called reshape. We're going to be reshaping to a wide format, and it's going to, the ID variable that will be unique for every row will be our zip code, and our time variable will be the week number. So if you're interested in this, I highly recommend, you know, just checking out the tidyverse and dplyr libraries more specifically, because they're just amazing data formats or data libraries. So here we can see now that instead of having to filter for one specific week and then losing all the other data, we now have case data by week in this totally different format. So this will be really powerful for different GIS and mapping analyses in the future. Okay. So that's step number one. Next step is let's merge this to a zip code level data set. Okay. So we're going to take All right, so we have a row that has a value of unknown. If you were to, we're going to save you a little bit of troubleshooting and just tell you that that's going to happen. So there is a row that is unknown. We're going to kick that out so that now we have just a clean data set. And next, let's bring in our zip code data. Okay. So this is a zip code file. You can grab one off the data portal. Again, there's a lot of different resources about how to find boundary data online. But in this case, we're just giving you an example of pulling data that is in a zip code format, just to give you a little bit of a variation from the shapefile. So for good practice, I might want to look at it to see what's in there. And this data set actually has a lot of information. We have the zip code, but then we also have all of these different socioeconomic indicators that were already pulled in. So we have total population, racial ethnic breakdowns that are self-identified, age breakdowns, and so on and so forth. And this is in a polygon format. So how is our zip code included here? We have it as a zip code or just zip in lowercase. And then up here from our epi data set, it's capital zip.code. It is the 5-digit zip code identifier. Our toolkit has a whole section about issues with zip codes, and you can read about that later. So here, let's look to see what kind of distinct zip codes we have. Okay. Oh, well, it's already distinct. Okay. So this is just a little bit of cleaning that we give you. Okay. And we can go into this later. I know we don't have too much time today left, so I want to just kind of jump a little bit further. But these functions, group by, slice, ungroup, this is also coming from dplyr. So if you're not familiar with dplyr, definitely like that's going to be a very big friend of you when you're data wrangling. But here, all right, so here we're going to merge. There's many, many different ways to merge the data sets. In this case, we have a clean zip code data set, and we're going to be merging our COVID data to that. So this is our zip code level data. We're going to left join, which means we're going to include all of the records of zip code plus anything that matches from this data set. So if there were things that didn't, that if this data set had fewer zip codes, it's fine. We would still retain all of the zip codes from our master data set. So we're going to merge our COVID data to our master data set right here of the zip code. And if you want to like even look at that to just get an idea of what that looks like, let's see what that's called. Okay. It will kind of give you a little plot down here to look at, so you can see how the zip codes look in some of the different variables that are being shared here. On the left-hand side, our zip code master data set has zip as our key. And then on the other side, our COVID data set has this as the key. So this is where we're assigning these two keys to be the same. So we join that. And if we look at our join data, we can now see that all of those different case rates are now added to our data set. Okay. So at this point too, we could potentially, write this as a CSV if we wanted to. We could write this as a shapefile or a GeoJSON. If you look through the toolkit, there'll be some examples of how to do that. Okay. But I know we don't have a lot of time. So moving on, let's do join by location. So going back to those affordable rental housing developments that we looked at, this data did not have. So we have a lot of information in this data. Oh, shoot. We'll just give this a couple more minutes. We have a lot of stuff here in this data set, but we do not have the census tract information. So how do we do that? And let's see here. Okay, so in this case, we've already included this as a data set. So what's pretty neat is the same join function. So this is a non-spatial join. For a spatial join, we actually use an SF function called stjoin. So for one example, maybe we want to bring all of let's bring this to a tract data set. Let's say we want to bring all the Chicago census tract information and then stick that to the housing data set. We take our houses and then we're sticking the Chicago tracts to that, and we're going to use an intersects, like whatever two things intersect will give us that information. Okay. Oh, and then, oh no. So I think that might be I think I know what that is. I might be because I'm messing things up a little bit here. Aha. I think this is because we have not turned our housing data set. This housing data set has actually not been turned into a spatial data set just yet. That's what happened in this example. I thought that we did that up here though. Yeah. Okay, there we go. So here now, if we look at this joined data set, you can see that all the information for the points is still here. But then you've also added all the tract information. So now you have the GeoID of which census tract each of those points falls with. And from here, you can start to do a lot of different work. I'm not going to go through this last step, but if you go down here, another way to do it is to flip it around to count how many developments intersect each census tract. So here we use lengths to find out how many items are present in a vector. And here it's flipping things around. So here it's counting housing developments by zip code. In this case, we're counting them by zip code instead of census tract because there aren't that many housing developments across the city. So otherwise you'd get a lot of zeros. But if you do that and then map it out later, you've basically created this brand new variable that is total housing by zip code, which can be really powerful. But I know that that's probably, we're going to stop things for now.